Hi, this is Rex Carden with the University of Alabama at Birmingham. Today I'm going to talk about how to implement TG-263 structure name compliance at your institution. We just recently published a paper in JCMP September 2019, and it just goes over some things that we did and to try to improve it at our clinic. And we basically started with structure templates, like most people would do. And then we showed that with scripting, you could really lower your errors to very close to 2% or less. So we published this library. It's called ESAPIX. It's on GitHub. And I want to show you how to use this feature of that library. So here we are on GitHub, and we search for ESAPIX, and you can see it's under Rex Carden ESAPIX. Then if you go down to the helpers folder, structures folder, you'll see this TG-263 dictionary class, which has all of the source code for kind of the magic of what we're going to be demonstrating in this video. So this is just for you if you wanted to pull this out and build your own standalone library. You don't have to have this tied into Eclipse, but that's the way we structured it. It's built into our Eclipse scripting API extension library. So if you want to use this, I'm going to show you how to do it in .NET with the Eclipse scripting API. So you can start a new project in Visual Studio. Go to, let's do a console application, .NET Framework. And I'll just call this TG-263 demo. The first thing you're going to want to do is to reference the ESAPIX library so we can use that dictionary. So if you go to right-click your project, click Manage NuGet Packages, and in the browse, you can type in ESAPI, hopefully. And you can see there's lots of libraries up here. The one we're looking for is it's got these X's called the ESAPIX library. And I'm in version 15.5. So I'm going to click on that one and press install. It's going to prompt me to install some dependency libraries, the JSON library, the value tuple, and then the ESAPIX. So I'll just go ahead and do that. We also need to reference the Varian DLLs. So on my computer, let's see, make sure I get the right ones here. It's under C program files, x86, Varian, RTM 15.5, ESAPI. So this is not a 101 course here, so you should know where those DLLs are. Press OK. And we are good to go. You do also need to make sure that your project is set to x64 because all of the DLLs are 64-bit DLLs. So normally when you're programming Eclipse scripting against the library, you normally use the STA thread and you do something like using as the app equals, let's put a variable up here to help us out. Just put in a little V to abbreviate this long namespace. You would say v.application, create application, and then you would do all of your stuff in this block of code here. When you're using you can actually do this in the ESAPIX, but I prefer to use a separate thread. That way, if I'm doing a real application, I can just take this out and it will kind of run in the background by itself. So in the Eclipse Scripting API X library, there's this concept of a common thread for the application that the Varian stuff is going to run on. So it's going to run separately from this console, and you can actually pull this STA thread out if you're doing this, because your console app does not need to be an STA thread. Whenever you use this architecture, you have to set the context, which means you have to call the, just like we did before with the using statement, you need to initiate the application. This is gonna set up a kind of a plug-in context kind of feel on the back end. I'll show you what I mean. Just paste some code in here instead of typing it out. So every time you want to call the thread, you use the instance, and then you can call this execute method, and that'll execute whatever's inside this block on that background thread. So that's what we're doing here. Nothing super complicated. And again, you do not have to do this. You can do that using block like I showed earlier and do the standard ESAPI calls. In this case, I'm setting the patient to that test patient, PT underscore, all that. I'm going to set the course to the first course. I'm going to pick the first plan. I'm going to grab the structure set from that plan, call it SS. I'm going to loop through all the structures in that structure set, and then I'm going to call this checker. Let's make this checker. This is where we're going to call the ESAPIX library, TG-263 dictionary. So I'm going to make a variable up here. I've got the red squigglies. So I'm going to click the light bulb and just call the using statement. So you can see that was in that namespace here. And what you want to do on this class here is you call the getNameCompliance method. You pass in the structure ID, and then you can see some of this stuff back here. This is for asynchronous methods, which is what this is. This is designed to run kind of asynchronously in the background, because it actually can take some time depending on how many structures you want back. But the biggest time sink here is when you initialize the dictionary. It's got to read in a lot of regular expressions, which we use to validate the TG-263 structure names. Anyway, when you call this method, you're going to get two things back. You're going to get a Boolean indicating whether it's okay or not, whether it passes. And if it doesn't pass, it's going to give you a list of recommended names that are similar to the structure name that you input. So we found that that helps our dosimetrists. In the case that it's wrong, it helps them find the right name. It's not perfect. We're still working on this to make it better, but that is what it does currently. So what I've said here is if it's not okay, write out the structure ID, say it's not compliant, and then let's also add a little line that says maybe try, and then add some recommended names. And also let me just add a little empty so we can get some space between our invalid structure names. So let's go ahead and run this code. We should get a little console app running here. It's going to show us all the structures. And this is the part, it's loading in all those regular expressions. It takes just a second for this part. So you would typically do this when you initialize your application, because once it's built, it can do these calls pretty fast. You'll see once it starts executing, it does them very fast. So you can see we got a lot of non-compliant names here. Oh, I forgot to stop with a console read, so we can actually read that. I'm gonna run it again. I'll pause the video while it runs. Okay, this time I've actually got some of the outputs from the console, and you can see here. And you'll see it's really not perfect. But you'll get things like this. So it says mandible is not TG. So this is non-intuitive. Mandible is not TG-263 compliant. And then it says try this, bone underscore mandible. So it's pretty helpful on things like that. You can see here the optic nerve left is wrong. It's telling you, first try, it's telling you the right name. So it does have some handy things. Some of them will be wrong on the recommendations. You can see here some mandibular left. It's suggesting the fibula left first. So it's obviously not right. But the third option is actually correct. The gland submandibular L. So like I said, a lot of times you won't be able to know unless you just know these off the top of your head. They're relatively difficult to guess until you get familiar with them. So this library does help you. Not only tells you if it's wrong, it proposes the correct name to you. So hopefully that can get you started with it. And if you have any problems, feel free to post to the GitHub in the issues column, and we'll see what we can do. Thanks.